us for a new version of the Relatorium seminar. Today, we are very happy to have with us Antonio Vassallo, who is a philosopher of physics, or he might tell us more about that. He's joining us from Warsaw, and he will talk to us about rethinking reality without space and time, a relational theory of how time comes about. So I'm all ears. Antonio, take it away.
Okay, thanks so much, Ted. It's great to be here. So let's start our discussion. Point. Physical theories. Modern physics can produce very accurate empirical predictions that can be tested, and they're tested and they are empirically successful. But we can also use physical theories to do some practical work. We can send probes to distant planets using physics. So as a philosopher of physics, the question that I'm interested in tackling from this point of view is how is it that physics works? We cannot just say that it works by chance. It seems that it captures some salient feature of the external world. So the type of question I'm interested in researching is how might the world be such that our best physical theories work as well as they do. Now, the type of answers that I seek for these questions concern, first of all, an inventory of what there is. So an ontology, as we philosophers like to call it. Okay, so we like to know what exists according to our best worked out physical theories. But also, I'm interested in characterizing the existent. So to know how the things that exist really are. And this is a broader metaphysical question. So in a nutshell, I'm interested in the metaphysics of physics.
Now, can I ask you a question? Sorry, Antonio.
Sure.
And in the interest, I didn't say this up front, but obviously, you know, because we've talked about this, I want to keep this, you know, interactive and
absolutely
sort of involve the audience at various points when it feels appropriate for you. But I want to start by just poking a little bit here. So you are saying that your interest is also in the how of existence, not just in the what exists. And that seems to be not that common, and a kind of an appropriate connection with our categorical perspective, things that we try to promote here with so our relatorium. In other words, that existence, rather than being thought of as entirely a priori, might be something that at least we can describe as arising through relations, through the ways in which things interact.
Yes,
just
absolutely.
Cue.
Yeah. Okay. Yeah, you are totally on target. The point is exactly that. And what is nice, I think, is that we can reach this type of result by starting in a totally neutral way. So if we get our inquiry in a totally, let's say, non-biased way, so we just ask questions, it seems that the more we think about the challenge, the more we are drawn to, let's say, having that conclusion that things are all related, and that's what characterizes the plurality of the existence. So, so you may say, you asked this question. Can't this question be answered straightforwardly? So we say physical theories talk about particles, fields, space and time, case in point. So it seems that it is very simple to answer the question that I raised. Just take our best worked out theories, look at the most important theoretical terms that are involved in those theories, bang, you have your ontology for the physical world. Well, this is, it may be a justified reaction prima facie, but if we think about that, there is a problem. And the problem is given by the fact that physics, as any other science, advances, progresses. So the theories that physicists endorsed, I don't know, in the 19th century are very different from the theories that we consider well worked out nowadays. And we already know that theories like general relativity or even quantum mechanics are very likely to be supplanted in future. So if that's the case, and we have this continuous progress of theories where the theoretical terms either seem to change their meaning or they totally are lost. So think about the initial ways in which electromagnetic phenomena were explained in terms of the mechanical vibrations of the ether, right? And then all of this was totally put aside in favor of Maxwell's treatment of electromagnetism. So you see that here we have a progress where some terms are totally cancelled from the equations. So
Antonio,
yes.
may I ask a question here? I'm not what you're saying is making me think of statements I heard before from physicists like Alan Lightman or Max Tegmark, to the effect that, for example, what an electron is simply the solution to Dirac's equation. There's nothing else that we can say it is. It behaves in various ways that are like physical things we might be familiar with, but essentially an electron is just that. Is this what you're talking about, or
so this
how does it relate to this sort of mathematization of what is?
So this is a possible reply to the challenge you see on screen. But it is a reply that leaves me unsatisfied, because in a sense, it means giving up the quest for finding an appropriate ontology for the world. Instead, what I endorse, what I will go for, is a response that can be traced back to Henri Poincaré. So the problem with the progress of physics was very well known back in the 19th century already. Okay, so Poincaré famously tackled this problem by saying, look, if you think that understanding what the world is according to a physical theory means pinpointing the individual entities that exist according to the theory, you are doing it wrong, because that's exactly what is prone to the problem of progress. When we say that a physical theory works, so it captures some aspect of the world, what we are meaning is not an intrinsic aspect of individual entities, but instead that aspect is a relational one. And this is exactly what he says in the quote. So when you have an equation of a physical theory that gets things right, so to speak, it's because that equation expresses relations. And if the equations remain true, it is because these relations preserve their reality. And they teach us before and after that there is such and such a relation between something and some other thing. Only this something we used to call motion in an ether theory, we now call electric current in Maxwellian electrodynamics. So
would you say then that perhaps the relations are more real than the things that they relate?
Yes.
Yeah, in other words, those are the things that are being related, are contingent words that we use, which might change as a result of progress, as you say. We might find better words, but that the relation, in some sense, the thing that holds together, the nexus that holds together whatever things we end up populating on the nodes, something to that effect.
The bottom line is exactly that. And if you depict a situation in which you have individual entities being related in some way, you are getting the things, let's say, in reverse. Instead, it is there is a relation, and from that relation, you can, if you want, reconstruct the relator. Okay, so that's exactly where I want to end up. Okay, so the response to this challenge, yes.
Just if I just like to make one comment. When I go out at night in a clear sky, I see stars and I see angles between them. I find it very difficult to get rid of both of those. If there weren't the stars, I wouldn't be aware of the angles, and those are the relations, Antonio.
Yeah, but that's an observational perspective. You are a subsystem of the universe. So in order to make the rest of the universe intelligible to you, you will use those things as anchors to individuate the relations. But the fundamental reality is just relation. So in a sense, your experience of seeing the sun, seeing the stars, is a relation itself. Okay? So the point is that there is a difference between ontology and phenomenology, if you want.
So is to build on Julian's really appropriate, I think, example, very grounding example. Think of the ancients, for example, ancient Greeks, right? That coined even the term planet, right? Mm-hmm. They could see patterns of movement between the planets, and very accurate, to some degree, quite accurate, actually, when they had no idea what the planets themselves were. They had very fanciful notions of that. Mm-hmm. And over the course of progress, we now understand much better, but still we have limits to how well we understand the physical nature of the planets. But that hasn't changed the relation, the movement, sure, the relative angles, the observation. So is this the kind of thing that you have in mind, that in some sense there's a deeper reality to the relations that is quite beyond the need to or the desire that we sometimes have to disambiguate what is being related?
Yes. The idea is that once we fully characterize how what we call things are related, we gain knowledge about the things related. And that's sufficient. We don't need to characterize things as intrinsic objects. So when we have our ephemeris tables with all the movements of the planets, what we need is exactly how they move with respect to our vantage point. And that's the salient information, okay? That's basically how I think things should be framed.
But to play devil's advocate, and I think perhaps, I'm only guessing, I think perhaps, though, this is where Julian is going with this. Presumably our desire, our intrinsic sort of drive to assign some real ontology to the things that are being related is because we believe it will help us explain the relation. It will help us to figure out some laws that relate, for example, in this case, gravitation, or even in the context of ancient Greek mythology, like the whims of the name, the named gods of the planets, or whatever it was. But there's some explanatory power that presumably assigning an ontology to the things has for us, or at least we think it might have for us. Maybe you're saying at a deeper level that that's not necessary, that in some sense the relations themselves can form a causal nexus, some explanatory modality that doesn't rely on us knowing properties of the objects themselves. So it's more than just saying we can describe it that way, but also that we can infer deeper properties, laws, explanatory modalities entirely relationally. And that's a much deeper statement.
Yeah, that's the point. But
I must say, if I can come in, I must say I struggle a little bit with that. I really like the early Greek definition of theory. It's to save the appearances.
mm-hmm.
And that seems to me to, you've got to, I mean, I think if I'm going to explain to my grandson, I see just wandering up to the house where I live, what all of this is about, I've got to show him the stars and the angles between them. I can't see how he can grasp anything without that. So I think there's got to be, my feeling at the moment is in a theory, there's got to be something which is a thing and there's a relationship between the things.
But you know, if you don't know what a star is, you just see a light in the sky. What's that? You don't know. It's just a light in the sky.
But I do see it as a point, and I see angles between it.
Yeah, and those are the relations.
Hmm?
And those are the relations. So
yes,
the
but
point is that
I wouldn't know what the angle is without the stars. If all the stars are taken away, there's nothing. That's my problem, Antonio.
So relations are the way things are. So if you look at a light in the sky, you are just seeing something. That something is not the true nature of what you see. It can be whatever. It can be, I don't know, a light bulb. It can be a sphere of plasma. You don't know that. You just see the light.
Yeah, but I could constantly revise my idea of what I'm seeing.
Sure.
And I say that is exactly what has happened. Now we have a much better understanding of what stars are, but it's constantly being revised. I mean, stars are now sort of
No, you're right.
nuclei moving relative to each other according to the modern things.
Yes, you're right. But that's the point. So you see, I can see angles and so on and so forth. That's right. It doesn't matter whether the light you see in the sky is a ball of plasma, it's a light bulb put there. The relations that you see,
Antonio, I suppose,
are there.
and let's give Lorenzo also the chance to say what he thinks. I think the point that Julian is making is that there's something there. There's something there of which the angles are a distance measure. But let's Lorenzo, what do you have in mind? You have to unmute yourself. Sorry.
Since there is there's little chance that we might get to the end, so I might just make my point now. I'm not sure. Maybe I think I agree with the question. Maybe I'm just reformulating again. But I'm not sure you get from an epistemic observation, namely that since our theory change all the time, what their ontology is and what they seem to say at face value, or they will change over time, then it seems that we might not know what the fundamental ontology is, what the objects are. How do we get from that epistemic claim that we might never know exactly what there is to the claim that, well, maybe there are no objects to begin with, or at least not fundamented, there are only the relations. It seems to me, remember the parable of the fox and the grapes? When when you see the beautiful grapes are the ontology we want to know what there is, then we realize that we cannot touch them, and so we think, oh well, they are undesirable.
I love that statement. For me, and I think I mentioned it to you, Antonio. This concern shifts my gut feeling more in the direction of epistemology than ontology. I'd rather be more kind of more open to different possible ontologies, as long as the things that can, so in other words, it's a perspective of what can be said, and without that meaning any reduction of importance. For me, all that matters is what can be said. And so I think if I can't say anything more about what the things are in themselves, that doesn't stop me from being able to say more about the relations between them, and that maybe it's easier for me to understand, the primitive existence of the things, the objects themselves, as a result of or reasoning from what I can say about their relations. Which, after all, is to some degree what has happened historically as well about stars, in terms of understanding gravity.
I see your point. My position is more radical than that. And my idea is that an appropriate metaphysics for physics should inherit the, let's say, empirical content of a certain theory. What I mean? I mean that we should grant ontological status only to what can be, in some sense, verified or can make some epistemic difference. Saying that we can adopt an ontology where there are things that, well, actually we don't know exactly what they are in their true nature, but we can reveal them through relations, is unsatisfactory, because that will mean that there are truths about the physical world that are inaccessible in a very strong sense, not even in principle, right? So what I want to do is to propose a much more radical metaphysics, where anything that plays a role in our observations, in our in the way we see things, is let's say part of the ontology. So Poincaré himself, in the quotation I gave, that was of course a much longer passage, he says something like, those relations hold among things whose true nature will always be hidden from us. That part I don't like, honestly, because it depicts a reality which that we cannot really access and understand in full with a metaphysical investigation. So
I think all of us, actually, several of us probably have important things we would want to say at this point, but I'd rather here, I'm willing to suspend my desire to say more at this point until later, because I want to hear where you want to take us with this, to see perhaps, surprise us. What useful thing comes out of this?
That's okay.
Yeah, that's great.
That's okay. So going back to what Poincaré said, the way we can now reply to this challenge is just to accept there is a change in the theoretical terms that are involved in physical theories as physics develops. We maintain that the way such terms are related is preserved through theory change, and in this way we can at least epistemically answer the challenge by saying that past theories were successful insofar as they captured those relational aspects. But now we want to bring this lesson to a higher metaphysical level, because it will become handy in understanding what space and time are. So if we want to implement this idea in a metaphysical stance, we can propose something that is very well known in the literature as ontic structural realism. So in a nutshell, the fundamental stuff of reality isn't made of individual things placed in space at the time, but it is the relational structure itself. So at bottom, what exists is this huge structure, this pattern of relation. And in doing that, I will show you, hopefully, that we can consider space and time as just useful systematizations over these relational structures. So when we want to describe that structure, when we need, let's say, handles to make that structure intelligible to us, we can use space and time in a sense that I'm going to make clear later. But at this point, of course, we need to acknowledge another worry, which is an indispensability one. So we can propose these radical structural metaphysics as much as we want. But that doesn't change the fact that our current theories rely on spatial and temporal notions to make the connection between theory and observation manifest. So we cannot just say, okay, yes, physical theories talk about space, time, mass, charge, intrinsic properties, that's okay, but we just say that those things are not real, or at least are not fundamental. That would not be acceptable from a philosophical perspective, would be just something very arbitrary. So we need to do some work.
Antonio, I think there's a more fundamental concern that I have at this point, which is, I mean, this one is a technical concern in the sense that who is to say that we can't come up with a theoretical description that's analogous, that's equivalent, that makes equivalent predictions to the canonical one that is entirely relational. So this is a technical question. Maybe we can reformulate, for example, general relativity in entirely relational terms. Maybe not. And some people have certainly tried to do that. But my problem is with something you said when describing your goal, which isn't written here. You said that space-time, for example, is a useful systematization of the relational structure in order to make it intelligible, or to make the structure intelligible. So you seem to be fundamentally reliant on intelligibility, but you haven't defined, you mentioned intelligible here, right? But you haven't defined that. So in other words, what renders one formulation intelligible and another less so? Might it not be a feedback loop? For example, just because we're familiar with some concepts, with some words, with some vocabulary, it's like a language that we use. And so that becomes more intelligible. And then you're trying to teach us perhaps a different language. The reason I use this linguistic analogy is because that's often how we think about category theory, as a translation mechanism, essentially. But, in other words, is there something fundamental to be said about how we render something intelligible, or what it means for something to make sense to us? Or is it simply just a matter of different words that we take as primitives, like different axioms that we start with?
So here is what I have in mind when I talk about intelligibility. So even we start doing physics, okay, we have some pre-theoretical links with the external world. So we perceive the world in a certain way. So we have objects, those objects endure in time, they move in space. That's the way we come to know the external world. So when you invited me to this talk, you gave me some very precise indications of how to do that. Let's meet at 5:30 p.m. Warsaw time. let's connect to Zoom, and so on and so forth. So those things, that information is the thing that makes your invitation intelligible to me, that I know what you want from me. Now, that's the type of approach that I have in mind here. So you can have your theory that just talks about, I don't know, some function, a Lagrangian, or even a wave function, if you want, which is defined on a higher dimensional mathematical space, and so on and so forth. Now, the problem is, what is it that grants physicality to the information you want to convey with your theory? The fact is that if you do not come up with some links that let me understand how these mathematical things is projected in a space-timeful setting, I will have doubts regarding whether it is something physical or it is just a mathematical construction. So that's the point. We cannot, so this is the idea. Space and time, the problem with getting rid of space and time is this one. Those are the things, the handles we use to make sense of the world. So if we say, oh, you know, the world fundamentally do not feature space and time, and we have described the world as it is, we need at least to come up with a way in which from that fundamental reality we get to experience a space-timeful setting that makes sense to us. So this is, in a nutshell, intelligibility for me. So it's the thing that grants physicality to a description. I hope this clarifies a little bit.
Thank you. Yes, it did. I like that.
So here we are. I am, judging from the reactions in the audience, just me. I am the only radical structuralist in this meeting. And so I don't like space and time. I want to get rid of it, but the most well-established physical theories have space and time in their vocabulary. How can we do that? How can we implement a framework for physics that, let's say, helps us not only get rid of space and time in the physical description, but, and most importantly, according to what I have already said, how comes up with a coherent story regarding the way space and time, let's say, emerge. This is a verb that philosophers don't like to use because it has a lot of connotations. But let's say in scare quotes, how space and time emerge from this setting, okay? So here, thanks goodness, people much more smart than me have already discussed this whole problem at length. So the idea of coming with a description of dynamics that does not rely on space and time as fundamental entities, as sui generis entities, is a long-standing debate that dates back to Leibniz. Of course, a pivotal role was played by Ernst Mach, and of course, modern relational physics, the entire program was started by Julian. So those people made a lot of work already. So in a sense, I'm standing on the shoulder of giants because I can exploit the technical results that these people have achieved in order to let's say, justify my entire framework. Now,
Antonio, I
yes.
think I would be remiss if I didn't mention at this point that if I was to just see this, I would assume that time is simply captured by a reduction in hair. That's the most prominent pattern here.
Yes,
but
that can be an account of time.
Julian.
If I may come in, thank you very much. It's very flattering to find myself next to these two giants. To come back to me and the stars and the angles between them, Leibniz said space is the order of coexisting things. And when he was pushed by Clarke what he meant by order, he said distance.
Yeah.
And distance, I would say, is common to Leibniz, Mach, and certainly me. I think I would certainly be happy to, and a lot of my work has been trying to get rid of time as a fundamental concept, but I find it very, very hard to get rid of distance from foundations. Very, very hard.
Totally agree. This is still an open issue. Absolutely. Totally characterize the order of coexistence without any spatial or even geometrical terms is a challenge. So, of course, I'm not presenting here a finished, fully worked out framework. There are things we should work on. So, yeah, I totally agree with you on that.
Interestingly, and I think Julian and I think Julian, we spoke about this briefly a couple of years ago, but I think this contrasts with Lee Smolin's idea, where I think, if I understand his perspective, he finds it easier to get rid of space than time, at least in his more recent version.
Well, in his book on Time Reborn, he certainly goes that way. But I must say, I mean, Lee's a good friend, and we've collaborated quite a bit. But I've really parted. I'm rereading his Time Reborn at the moment now, and I just think it's not going to work. I mean, certainly. I mean, just to complete what Leibniz said, he said not only space is the order of coexisting things, he said time is the succession of coexisting things. And I think it's very hard. I find it very, very hard to get away from that. And I'm now come to the feeling, I'm now exploring the possibility that the things are just mathematical points of zero size. It's wonderful things you can do with things of zero size. Above all, it's perfectly easy to immediately express the fundamental symmetry of three-dimensional scale invariance, which I'm thinking more and more is an incredibly neglected symmetry. It's when, to come back to the stars, when we look at the stars, there's lots of angles between them. So these are ratios because they're ratios of 2 pi all the way around the sky. So I talk about the ubiquity and interconnection of ratios. They're all connected with each other on the sky. And that seems to me the key thing. Those are the relations, but I don't think you can formulate them without the sort of distance, the angles. And they're pure numbers. The other thing is angles are pure numbers because they are ratios.
To push back from a mathematical perspective on this, you know, when you say distance, and in this case, of course, you use angles as the metric. I think what you're trying to get at is some notion of topology, essentially a metric topology in this case. And I wonder, I mean, we can leave it open. I'm just, where my mind is going at this point is, might there not be intelligible theories that are more abstractly topological without necessarily a metric structure support? So in other words, local theory, you know, theories that have a notion of locality, you know, some neighborhood structures and so on, that are not necessarily metrizable. Might they not be intelligible. But
personally, I find it very difficult. I think it's very significant that Riemann, in his great 1854 paper, with the first really clear formulation of the notion of a bare manifold, he washed out all structure, first of all. I think it was a scandal. He got rid of every bit of variety. Leibniz says variety is the beginning and end of everything. Riemann got rid of all of that. Then he imagined coordinates on top of that bare manifold, imagined them like we actually see stars in the sky. And then finally he says, and I'm not sure if I get the mathematics quite right, but if they're not too far apart, then Euclidean relations, distance relations hold there. I just think that I think Riemann might turn out to be the biggest con trick in history, great as he was.
All right, Julian, we have you on record now for that.
Wow.
Antonio, or sorry, Matt, did you have something to add?
So, Julian, at some point I'd like to know a little more about what you mean by get rid of distance or not get rid of distance. I really don't quite understand that directly.
I don't think I personally don't think you can get rid of distance. Riemann.
That's my question. That's part of my question is if someone were going to try, what would they need to accomplish in order to actually get rid of distance? Because you've got to talk about what you mean by distance, right? So is a distance actually a number or is it a referent?
I would say the basic number for me probably is 4 pi, the area of a sphere, the sphere that we see when we look at, if we were an astronaut in space, it's a pure number. Distance for me derives from some pure number. Every distance we measure is a ratio. It's a ratio of how many times the ruler fits into an interval.
Okay, but then you're using things that are often referred to by non-Platonists mathematically as things that don't exist, numbers. They're not physical objects. So I don't know. They're presumably not physical objects. To Platonists, they exist in some serious sense, and Neoplatonists as well, but But the formalists in mathematics deny the existence of those things, essentially.
Well, I'm not a great expert on the foundations of mathematics. I think I have a more or less a decent understanding of the real numbers. And so my ontology is points separated by a real number.
Okay.
So I can translate what I'm saying about seeing the stars on the sky into points in space. But always, I mean, my guiding motto is nothing but ratios. And it's incredible. I mean, it's an amazingly ignored. Look at Einstein's general theory of relativity. The fundamental concepts are proper time and proper distance. They're not ratios.
Well, that's why it wasn't entirely relational. I mean, you and I spoke about this, but it's fairly well known by now that he gave up on the fully Machian presentation.
Yeah, but he also said that he'd committed a sin in that he had not shown how rods and clocks emerge out of the equations of his theory. It's a mortal sin. I gave a brief talk a year ago, a lightning talk at a Google unconference, and it was a 10-minute talk, and its title was Einstein's Mortal Sin. Just a sin. I think it was a mortal sin. This is not to deny the incredible success of general relativity. I'm not. But I think work with which I've been involved with a lot of very competent collaborators has shown how much more relational you can make general relativity. This all started, I would say, with Dirac, when Dirac said if you're going to quantize general relativity, you've got to reintroduce simultaneity.
Right. So I think
on a related note, Julian, real quick, it seems like part of the discussion here is that it is possible to get rid of time, but not distance. And so what has been accomplished, in what sense has time been eliminated that distance cannot be? That's part of my question is, what's it mean to eliminate something?
Right. Well, let's see. I think Antonio has something to say about that. And I think,
okay, good.
I think also that part of what he has to say might be answering also what Julian was saying. In other words, a more relational view of a more purely relational view of general relativity and the question of time in general relativity.
Sure. Okay. So yeah, so Matt, of course, pointed the finger at the problem. So what I think is that we can consider the mathematical notion of distance and the number that can be assigned as part of the description. Now, the challenge is to describe the, let's say, what philosophers call the supervenient basis over which that mathematical description can be placed. So my feeling is that distance, the numbers, the metrics, and so on and so forth are a way, once again, to make that fundamental relation intelligible. But it is not part of the ontology by itself. Now, of course, it's hard work to come up with a characterization of this fundamental relation that makes you say, okay, there is no geometric, no spatial notion involved in that characterization. That's an open question and is still work in progress. So you can ask me this question in a couple of years. Hopefully, I will be able to tell you more about that. So going back.
If time doesn't exist, we've already asked you that question somewhere. And
absolutely. So move to that part of the holistic structure to have your answer. You mentioned Lee Smolin and his way to, let's say, look at time as something more fundamental than space. So here is the point. The work I'm doing here is in the metaphysics of physics. So metaphysics is something that, of course, cannot be adjudicated once and for all via empirical investigation. Okay, so we are not talking about physical theories per se. We are talking about how we interpret the conceptual framework that makes a physical theory what it is. So from this point of view, people can have different views based on different metaphysical tastes. So you can come up with arguments that can be more or less strong than your opponent. But of course, this cannot be, let's say, decided once and for all, I will say. So this is why I was once invited in a seminar by physicists, and that seminar was titled Exact Results in Quantum Theory and Gravity. And so I started my talk by saying, well, guys, if you look for exact results, you are off for a bad start with me, because I'm a metaphysician. So that's the point here. The guys that you see here on screen, in a way or another, recognize that whenever we, let's say, are committed to the existence of spatial and temporal structures as sui generis entities, we are committing ourselves to a huge lot of surplus structure. What does that mean? Well, let's go back to Leibniz, okay? I guess all of you are familiar with Leibniz shift arguments against Newtonian space and Newtonian time. So very quickly, the basic idea is that take a certain situation in which you have your absolute space, which is a container, right? And then you have the universal configuration of matter placed in a certain way in that container. Now imagine a second scenario where the entire material configuration of the universe is just rigidly shifted, let's say, 5 meters to the left with respect to the previous scenario. Now, if you think that the container is a thing, then you are committed to these two scenarios being fundamentally distinct, okay? However, you cannot have empirical access, you cannot observe absolute locations. So basically now, the only thing that you can see are the relations among the material content of the universe. But those are exactly the same in the two scenarios. So if you are committed to absolute space, but something similar goes for time, you are committed to situations where you have an ontological difference that makes no observable empirical difference, okay? And this type of reasoning can be shifted mutatis mutandis also in the context of general relativity. There is a huge debate regarding something called the whole argument. Now, I won't go into that, but the idea is that the very same reasoning applies here. So I will say that what we are seeking here is to implement a clear principle of ontological parsimony. So any empirically adequate ontology of the physical world should avoid entities, structures whose variation makes no physical difference, or which lacks explanatory power to account for said difference. So we are back to what I was saying in a moment. If I accept in my ontology things that are forever barred from my empirical grasp, that can have idle characteristics that I cannot discern in any way, even in principle. I think that if I am, let's say, empirically driven as a metaphysician, I will tend to regard those things as metaphysical ghosts, because there's nothing I can do to those things to gain knowledge about those. I can only postulate them, okay? So that's the point that drives me into this whole inquiry.
Yeah, can I come in quickly with just one thing?
Please, yeah.
Antonio, if you changed physical difference to observable difference, I would be in total agreement with you.
Okay.
I think it is important, because it's those angles between the stars that I actually see.
But that's the point. The physical difference is an observable difference. But okay, we can absolutely consider this just a verbal type of dispute. And
well, because the difference might be observable to whom? Is it in principle unobservable to anyone, or is it among the set of current observations we have, or from any one perspective? Or but I think for a moment Lorenzo had his hand up and now he disappeared.
I had the same question, exactly the same.
Okay.
So no, that's the point.
But
so,
a related, a related issue to Julian's question and to, or comment, and to Ted's question, two different observers might measure those angles differently. And so, Julian, the numbers are not as absolute or universally observable as the physical world is, as far as I can tell.
Yeah, but surely the success of science does give us pretty strong evidence that different scientists do agree. I mean, by and large, they come down. I mean, the angles. I mean, there's been this fabulous spacecraft. What is it, Gaia, that has measured all the angles between the stars in the galaxy and how they've changed and things like that. And nobody seriously doubts those angle measurements.
Oh, but I'm thinking two different observers in different positions might measure.
Yes, but they can.
It might measure them differently because of something related to parallax and so forth.
Oh yes, but then we understand how to take that into account.
Okay.
Right, but so my question is more metaphysical. I'll let Lorenzo ask. I think I don't want to be the one who's asked the question.
Sorry, just very quickly, I think one way to reinforce the point why I think it is correct you should probably change physical to empirical is because otherwise the point seems to be empty. Because even if I am a substantivalist, I will agree with the principle as you stated, because I will say space-time is a physical thing, then of course any difference in space-time, whether detectable or not, is a physical difference, because the physical thing is different. But so I would accept your principle, but it would be trivial. Instead, if you say empirical, then we get at the heart of the disagreement.
And by empirical, you mean what I called observational?
Observational,
yes.
Yeah. I mean, the metaphysical version of that question, I think, or addendum to that question, although I think it's captured in what you said, I believe, is that those two observers, for example, that Matt was talking about, might be forever out of causal connection. They may never know that one and the other exist. So it's a metaphysical statement to say they might exist, or your statement that they do not exist is a metaphysical objection. In other words, it's saying, I believe that the ontology of the universe is such that no two observers can exist that can tell this difference, irrespective of whether they know each other. This is knowable from within the universe. Do you see what I mean?
Yeah. So the point is, I would say, rather simple. Yeah. So if there is something to the world, we should, in principle, be able to access it. Now, different observers may give different descriptions of that thing. They may access that thing in different ways. The point is that, in principle, they can do that, and in principle, there is some sort of law that can relate the different perspectives. Okay, so even if the two are causally disconnected, I don't know, one observer ends up entering a black hole, so we lost him. In any case, in principle, if that observer could communicate with the other, then there will be a way to relate their points of view. So what I don't like are those features of the universe that are inaccessible in principle by anybody, and which make no metaphysical work. So yes, they do not explain anything.
Okay, Antonio, yes, I agree with you. I think said the way that you just said it, it makes more an ambiguous sense. It's just that space, that sort of gap that I wanted to point out, and it might very, I mean, I think it's just a gap and we can move on from it. But just to be very clear, is that who's to say, and you might make the ontological statement that is so, who's to say that there doesn't exist a set of a set of things, a set of anomalies, let's say, that could only be accessible if observers that are causally disconnected could communicate. In other words, I don't buy your argument that, you know, this counterfactual, if they could communicate, then they would get it, because there might exist that, you know, in principle, there might exist things that if they could communicate, they would realize there's this aspect of the universe, but part of the aspect of the universe is they could never communicate. I mean, this is not in some sense negotiable. We've taken it as part of the ontology of the universe that there will always be pairs of mutually disconnected observers. In other words, that the universe is such that it affords pairs of observers that cannot communicate their respective observations. So to say that even if they could communicate, that thing isn't there, is sort of that who is to say, right? We'd have to state it that there is a that there. I don't know if I'm making myself clear. I think language is limited, but are you getting the kind of distinction I'm trying to make? It is a marginal one, so I don't mean to make a big point of this. I think your statement, as you claimed it most recently, is unambiguous to me. But yeah,
that's okay. No, I take your point. I will think about that, and perhaps.
In other words, the incommunicability between some pair of observers, I take it to be a pretty primitive aspect of the ontology. So I wouldn't appeal myself. I wouldn't appeal to a counterfactual of, well, what if they could communicate and so on. So I would allow for things that cannot be known because of that.
Okay, that's duly noted. We can continue this discussion, of course.
I'm sorry as well. I'm sorry doubly. In this case, it is my fault as well. Time is running, so I want you to know, and I'm happy to continue this conversation off, kind of after we complete the live stream. But I think for the live stream, we probably should aim to end in the next 10 minutes or so. So, okay. If you could, yeah.
Yeah, so much of the preparatory work has been laid down, okay? So very quickly, this is the main rationale for going the route I'm going, and that's the basic idea underlying modern relationalism. So we want to define our configurations, our universal configurations in such a way that we get rid of all those degrees of freedom that are usually associated with external, spatial, and temporal structures. So we don't care whether we can shift or rotate or even scale the universal content, the universal material content. So we end up with basically shapes. So we quotient out all those degrees of freedom, and what we end up is exactly with that kind of information, which then can be mathematically implemented. So you take the starting non-relational configuration space, which can be, for example, the one for a Newtonian n-body system, and what you do is just you identify all those configurations that are related by rigid translations, rotations, and scalings. So now you can project down these to a reduced configuration space where you have, if you want, true motion. Namely, when you move through a curve here, what is changing is the shape of the universal configuration, not any type of information which is redundant according to this framework. So this guy here is called shape space, because each point in the space is a precise shape. What's important here is that the metric that can be defined on this space gives a measure of how different intrinsically two shapes are. So the closer two points are in this space, the more similar the two shapes are, in the sense that if you juxtapose the two, we have less and less differences as the gap is between the 2 points is reached. Okay, so that's the basic idea. Now, the most novel approach to defining a physical framework in this way starts from what is called the generalized Mach Poincaré principle, which is a variation on what Julian already proposed some years ago. So given that we don't need all that information related to an external space and time, a point in shape space and some intrinsic higher order derivatives are sufficient to completely specify the dynamic and development of the system. So very quickly, this theoretical framework can be encoded in this low schema. Here, QA is just a point in shape space, and the alphas are the geometric degrees of freedom of the dynamical curve traced by those equations. So the idea here is that you don't have just let's say tangent vectors to the point, so first derivatives. You can admit of higher order derivatives, so even the curvature of the curve and so on and so forth. So this is some sort of pure shape dynamics whose original...
It's some sort of dynamical system on shape space seen as a manifold, essentially. As a,
yes, that's...
In fact, maybe more appropriately as some sort of, I mean, there's some kind of Lie group structure presumed there, some sort of algebraic structure involved as well, presumably.
Yes, so this, I will give you all the technical details later in a reference. So you will find all the answers to your technical questions there. But
I come in with just one very quick comment.
Yes.
I wouldn't describe it as a dynamical system. I would just describe it as determining a curve on shape space, which just sits there.
Yeah. So this is why this is not...
And it's not a geodesic.
There's no time, so yeah.
And an absolutely key difference is that it's not a geodesic shape space. It's a curve that involves one more degree of freedom, which is what is actually bringing in an arrow of time.
I'm coming to that in a moment.
Oh yeah, sorry to anticipate it.
No, you're totally right. I appreciate that.
Yes.
And so this is exactly why these are not equations of motions, are more the equation of state of a curve, which is not defined in terms of any parametrization. We can introduce a parametrization at a certain point, but that will be just to make the calculations more simple. But fundamentally, there is no need for a parametrization. So we don't have that piece that may be linked to some external temporal structure. Now, what's important here is that this schema can be adjusted to the how, let's say, complex a system is. So the framework is in principle able to describe not only, let's say, Newtonian motions, but also much more complex motions like ones of general relativistic systems and even quantum systems. And some results we already have to this extent. The trick is to enlarge the number of degrees of freedom, the geometric degrees of freedom of the curve, in order to account for how much more structure the whole thing is. Now, the next piece that Julian was mentioning is this pivotal result that he, Tim Kozlowski, and Flavio Mercati found back in 2014. So the idea is that this dynamics is such that let's say the curve can be decomposed into two branches if you want. So this is an example that involves particles, but things can be let's say shifted mutatis mutandis to other physical systems. There is some work to this extent. So the idea is that even if you start with a very non-various configuration where the particles are basically distributed uniformly, the dynamics is such that the evolution will bring you to one of the two branches. And in these branches, there will be the formation of local and stable structures. So basically, in the Newtonian case, there will be the formation of these couples of particles that will start gravitating one around the other in a very uniform way, so that you can define notions of duration and length based on those which are called Kepler pairs. So in a sense, the dynamics is such that rods and clocks will emerge from it. And this can be encoded mathematically by using a well-defined functional over shape space, which is called the complexity functional. So this thing will measure how much, let's say, clustering in the case of particles will form in during the evolution. So the idea is that the dynamics will bring you to a branch where complexity grows secularly. Okay, so now you have a way to assign some sort of ordering to the subsequent configurations, to each point on the curve based on this complexity. So you can say that a configuration comes after another, just in case the value of complexity for this configuration is higher than the other one. Okay, so you have a way to define mathematically these type of things. And indeed, it can be shown that there are these ephemeris equations that let you define notions of duration, a notion of scale, just in terms of changes in the complexity. So you can recover mathematically a notion of scale, for example, just from the notion of this complexity growing over a branch of your dynamical evolution. Okay, so this is absolutely, let's say, it's very quick, not let's say mathematically rigorous, but we have time constraints, even if time doesn't exist.
The point of the seminar, the point of the relatorium isn't so much to, go into the technical justifications, but to create a conceptual space for making sense of it. And, and I think you're doing a great job of this. One final question that strikes me from this, just immediate, but I let you guys decide, between you and Julian, how to end this. But what comes to mind is I understand that deviations from the geodesic flow are precisely essentially a measure of time progressing, because I can see how, in some sense, if it was a geodesic flow, then nothing essentially would be happening. You wouldn't have an extra degree of freedom. And I understand that in some sense, this is, well, with what you just said now, measured by a progression of the complexity measure, right? I want to know how the two are related in some sense. Is complexity seen as the thing that's the driver of the non-geodesic flow? In other words, that's changing that like a force essentially on shape space, something that is pulling curves one way or the other. Am I understanding it correctly?
Well, yes, basically it is a way to rewrite the Newtonian potential in relational terms in this way. But putting things in this way may mislead some sort of dynamical structure that we don't want. So you can make this idea intelligible in this sense, in terms of forces, of Newtonian potential, and so on and so forth. But this is a way you make sense of that. The basic idea here is that at the fundamental level, you don't have anything like that. You just have your world is just let me just go through that. So you just have a collection of structures, which are self-subsisting because they are not in space and time. Those things are given all at once in a timeless sense. In this crystallized, if you want, picture, you can recognize, you can define a ordering in terms of complexity. But complexity just is something couched in terms of relational facts. It's not something over and above them. So in order to get your description, philosopher will tell you to look for the best system account of laws and dynamical structure. So even if your fundamental ontological level is very skeletal, there is basically just those relations, those structures laid down once and for all and forever there. You can show that if you set to give let's say, a logical system, a language system that describes that situation, well, the statements about laws and dynamical structures, including intrinsic properties like mass, charge, and so on and so forth, are just the simplest and most informative axiomatization of the totality of things laid down at the fundamental level. This is the best system account of laws, which can be, case in point, adapted to the defining space and time, because now we can show exactly through the ephemeris constructions that from facts that are fundamental and that are totally relational, we can construct those equations just as the simplest and most informative way to convey that fundamental reality. And that's the point. So in a sense, even if your fundamental, as philosophers call it, mosaic, is timeless, is just relational, is very meager, you can construct over that as a means of description the entire vocabulary of space and time. And this is the type of analogy that I use, the film stock analogy. So you have an animated picture of a horse riding, okay? But fundamentally, the whole thing is just a collection of frames that are ordered in terms of their similarity and shown in the appropriate order. That's exactly the same thing. So in this let's say, metaphor, let's say, the projection part is the way we describe and we get to know these fundamental reality. So those ephemeris constructions are some sort of Rosetta Stone. Okay, so you can at any point translate a fundamental vocabulary just in terms of relations to a vocabulary which is space-timeful. So in this sense, this framework reduces. So Matt was talking about eliminating. I would prefer the word reducing, because perhaps it better conveys what we are doing here. So we have a fundamental part which is relational, we have a space-timeful one, and that thing is just jargon, is just vocabulary. And we can at any point project it down to the fundamental part, okay? So as I like to say, in this picture, space and time are not fundamental entities, of course, but rather have some sort of phenomenal nature. They are what it feels like to beings like us to be subsystems of the universe, okay? So I think that this is enough.
This is a fantastic way to bring it together.
So for those interested, here are a couple of references where all that I have said very quickly, very unrigorously here can be seen, and of course here it is treated in much more depth and clarity. And of course I'm always up for discussions. I really appreciate your feedback, your criticism, because it is a way for me to better formulate my position, to make it stronger and stronger. So I really appreciate this opportunity that you gave me. And if you want to see what we are doing here in Warsaw, you can look at the website of the Philosophy of Physics group, and also the website of the current project I'm working on together with Lorenzo, which is a way to investigate how this relational picture can be translated to the quantum domain. So this is a framework in its infancy, but I hope I have shown that it has a lot of potentiality to bring about interesting and exciting results. That's it on my side.
Let's
Thank you so
thank
much.
Antonio, first of all. Thank you
Yes.
so much. This was fantastic. And maybe we can end the live stream just so we stay within the rough parameters of what we normally advertise. But then if you're available, we can stay a little bit longer on the Zoom and have, you know, put our hair down, as it were, and just like we can ask some more questions and talk.
Yes, I'm up for that.
Can I just say, I've got to go literally. Could I just say that?
Of course, yes, please.
Mostly, I agree with everything except underlying it, at least in the case of the particle work, which, with that very nice work you did with Tim and Pedro, distance between points is still absolutely the foundation of that. I mean, I just don't see at the moment how it can be got rid of that. But I'm afraid I've got to go now because I'm going to an event afterwards. But great to see you all.
Yeah, thank you, Julian, for coming. Really appreciate it.
Yeah, no, it's a pleasure. Yes.
Yeah, well done. Okay.
See you soon.
Irfan, you can end the live stream. Okay. So